Hi, everybody. This is going to be our last video specifically on decimals. And in this one, we're going to look at solving equations that contain decimals. Now, there are two strategies that you can use with solving decimals. And the first one is to just do nothing different. So strategy number one is to just solve using our regular rules, right? So no change or anything here. So for instance, let's do a couple of examples. So let's solve 1.2x plus 5.8 equals 8.2. And again, I know I'm not reading the numbers really correctly in their true form, but I think it just helps in a video to speak where the decimal point is. So I'm going to do that in this video here. Now, if you notice here, go back to your regular rules. So the first thing that you would do here, maybe we should kind of recap that, is going to be to really simplify everything that you can, right? So I'm just kind of doing a really quick recap here. So we would do things like parentheses. We could clear out fractions if we have them. You can also clear decimals, which I'll do in the next strategy. So right now I'm not going to do that. That's an optional thing. And then you can also combine like terms on each side of the equation. So if I look here, I don't have any parentheses, I don't have fractions, obviously I have decimals, but that's okay. And I don't have like terms on the same side, right? So if I look on the left side of the equation here, I have an x and a number. Here I just have a number. So there's nothing really I can do quickly to simplify. So the second thing I'm going to start doing is I'm going to add and subtract on both sides to combine like terms and get variable terms on one side and constants, so just numbers, on the other side. And again, I'm just doing kind of like a quick recap here. So the steps may not be exactly as detailed as I wrote before, but you have the right idea. So simplify first, now start moving things around. So once you can't do anything else that's easy, you need to start rearranging. So I'm going to just draw that line right through my equal sign. I have x's on the left, and I have a number on the right. So my goal is to maybe get this number on the right-hand side, right? Because I want to combine my terms, but I also want to separate my x's and my numbers. So I'm going to bring this guy over here. So I'm going to do minus 5.8. So remember, we do the opposite when we change sides. Now 8.2 minus 5.8 just is regular subtraction here with decimals. So I'm going to do a little bit of borrowing. I'm going to bring that decimal point straight down and keep going. Now I have all my x's on one side, all my numbers on the other. So remember, your last step here is to divide by the number with the variable. So my number with the variable is that 1.2. So I'm going to go ahead and divide that out on both sides. And that will still cancel like it always has. The only thing you have to do here is you have to do some long division now. So off to the side, I'm going to go ahead and do this long division. And remember that I don't like to divide with decimals, so I am going to clear that decimal out. And instead, I'm actually dividing 12 into 24. And hopefully you know that one off the top of your head, it is 2. So our answer here is 2. Now your fourth step, I'm not going to write it in, but you always can check, right? So if I plug 2 back into the problem here, I multiply by 1.2, I add to 5.8, I should get 8.2 on the other side. You should get a true statement. And I will say that solving with decimals is really not a big deal if you're using calculators, right? Because our calculator can handle the division and the adding and subtracting quite easily and quite quickly. So using the decimal and leaving it in decimal form like this is really not a big deal if you're using a calculator. However, we're not using a calculator right now, so it does make it more challenging. Let's try another example. So here's another example. Now here I do have a parenthesis, so I'm going to clear that out first before I get started. So I'm multiplying this through by 5. So 5 times x is just 5x minus. Now 5 times 0.36, I have to do that out. So like I said, if you're using a calculator, which we're not in class yet, it's really not that bad, but here it's kind of a pain. So 15, so I have 18, carry the 1. And then I have to count my decimals. 2 here, 0 here, so 2 altogether. So I get 1.8. Again, I can drop that extra 0 on the end. I look on each side of the equation to see if there's any like terms that I can quickly simplify. I don't have anything. They're all kind of spread out here. So I'm on to step 2 now, and I have to start rearranging. I notice that I have x's on both sides, and I also have numbers on both sides. So I'm just going to make a choice here. I'm going to choose to leave my x's on the left and bring my numbers to the right. So when they're on both sides, you can pick whichever way you want to go. So I'm going to bring my x's over here. So I'm going to add x. And remember, if there's no number, there is a 1 there. So sometimes that's helpful to write in. So here I have 6x minus 1.8 equals 2.4. And now I want to get my numbers on the right. So I'm going to change from subtraction to addition as I bring that to the other side. All right, let's see. 8 plus 4 is 12. So carry the 1. Here I have 4, and the decimal point comes straight down. Now everything is combined, so my last step is to divide. So I'm going to divide both sides by 6 here. And again, you may have to go ahead and do up that long division. If you're pretty good with your multiplication tables here, you may notice the answer is 0.7 right away. But if not, that's okay. Take your time. And you will see that the answer is 7/10 in this case. So that's our first strategy, is just don't worry so much about the decimal, is that you're just going to go ahead and solve as usual, following your regular steps. Now, the second strategy involves canceling out that decimal in the beginning. And to do this, what we do is we move all decimal points the same number of places to the right to create whole numbers. Now, technically, when you're moving decimal places to the right, you're actually multiplying by powers of 10. So when you move 1 decimal place, you're actually multiplying by 10. When you move 2 decimal places, you're actually multiplying by 100. When you move 3 decimal places, you're actually multiplying by 1,000, and so on. So the fact that we're moving all the decimal places is actually okay, because we're multiplying by the same power of 10 on each side of the equation. So I'm not actually phrasing it that way, right? We're kind of doing a shortcut. But it is okay, because you're multiplying either by 10 on both sides, or by 100 on both sides, or by 1,000 on both sides. So we are being consistent here, so we're not messing up our answer. And I want to do the same examples we just did, but using this strategy. So let me actually write it down first. Hang on. All right. So what I see here, again, you would still go through your same beginning steps. I do still recommend clearing parentheses first. I think that's the easiest thing to do. And then after that, you can go ahead and clear your decimals. And of course, if there's something easy for you to simplify right away, then you're welcome to still do that. So clearing out your decimals or fractions is always optional. But here I noticed that this one has 1 decimal point, this one has 1, and this one has 1. So if I move them all one decimal place, then I can clear all those out. So what we end up doing technically is we actually multiply both sides by 10 here, because 10 relates to one decimal place. I don't want you to stress too much about that, so just be consistent. Every term gets moved one spot to the right. And what you have now is 12x plus 58 equals 82. And now you should have a regular problem. So here I would subtract 58 from both sides. I would just keep solving now the regular way. And you'd have 24, and then I would divide by 12, and I would still get that same answer of 2. Now for the other example, I do still recommend doing parentheses first. It gets really weird here when there's decimals inside parentheses. They kind of cancel a little bit strangely. So I don't recommend doing the decimal first. I recommend still doing your parentheses first. So I know you still have a little bit of work there if you had to multiply this out, but I do recommend doing that first. You would get 1.8. Now here, notice I have no decimal places. Here I have 1, here I have none, here I have 1. So you want to use the max number of decimal places when you do this. So 1 is the max, so I'm going to cancel my decimals by moving everything by 1 decimal place. So I do this and this one, but I also have to do the whole numbers. So think about this. This is 5, right? So maybe I'm going to rewrite this for a second. This is 5, and the decimal point is on the right. So I still have to move that 1 place, so it becomes a 50. And this is -1 with the decimal point on the right, and I still have to move it 1 place, so it's going to become -10. So I'm actually going to end up solving the problem. 50x minus 18 equals -10x plus 24. So you do have to be consistent. Everything gets moved, even if it has no decimals. And then now I can solve the regular way. So I'm going to start by bringing this over. So I would add 10x to both sides. And if you have your other set of notes out from the first strategy, it's kind of interesting to just see the parallel in the numbers. It's just that there's no decimal places. Now I would add the 18 to both sides. So I have 60x is equal to 42. And then I would go ahead and divide by 60. Now, here's where it gets a little bit different. So you just want to make sure you see how the question wants your answer. Now here, I do see I have a fraction. So what I could do is simplify that first. I do notice that both of these can be divided by 6. So I have 7 out of 10 now. So your answer is 7/10. And if you remember your fraction notation pretty well, we can change this to a decimal by using that tenths idea. So the tenths place is 1 decimal point in, so we could rewrite that as 0.7. So you have your fraction form or you have your decimal form. If you forget how to do this with place value, obviously go back and watch the video, so that's pretty fast. But you can always divide. So you could always do 10 goes into 7, and then you could attach your 0 with your decimal point and get your decimal answer that way too. So sometimes you may get the answer in a different form, so just make sure you check carefully how do they want your answer stated. If it doesn't matter if it's a fraction or decimal, then either answer is fine. I just want to do one more example here using this shortcut strategy. And again, I'm going to use that shortcut strategy where I don't feel like working with decimals. I want to cancel them out. I don't have any parentheses here, so that's good. So I can jump right in with canceling the decimals. And if I check, I have 1 decimal place here, 1 here, but I have 2 here. So when you cancel, you want to use the maximum number of decimal places. So 2 is the max. So I'm going to move everything by 2. Okay, so this one gets moved by 2, but so do these. So it's 1, 2, 1, 2. And if you need to, rewrite that. 1, 2. So this becomes a 50y. Here, 1, 2. Again, this becomes a 230. 30 and then equals 165. Now that our decimals are all canceled, we can just solve as a regular problem. So here I have only just one term with a variable, so I'm going to leave it on the left side. I'm going to bring my numbers to the right instead. So I'm going to subtract 230. Now be careful here because we're subtracting a larger number from a smaller number. So think about this as adding a negative. So I'm going to rewrite the 230 on top and subtract it with 165. And then I'm going to remember that the 230 was the one that was negative. So it's not going to be positive 65, it'll be negative 65 for my result here. Now I can go ahead and divide by 50. So I have negative 65 over 50. I am recognizing that these are both divisible by 5, right? Because they end in 5 or 0. So I'm actually going to simplify a little bit first here. So I end up with negative, this would be 13, and this would be 10. If you can't do this in your head, that's okay. Just do it out on the side. And this is sufficient, but if I do want the answer in decimal form, remember that if we have a number divided by a power of 10, we can use a shortcut here, and we can move that decimal point one spot to the left. So my decimal point would be here, and then again, because it's division by 10, we're going to move left. So this becomes negative 1.3 or negative 1 3/10. Now, both of these answers are good. They're both simplified. It just depends on how that specific problem wants your answer written. Usually when we start with decimals, we tend to like the answer in decimal form, but just be careful there as you're reading directions. That's usually a common mistake that students make, is they put it in the wrong form. So you just want to be careful there. But hopefully you like this little shortcut. Again, I tend to like it a lot. I just find whole numbers easier, as I think most people do. But working with the decimals is not bad, particularly once we get to the point of using your calculator. So at the end of the semester, you'll be able to use your calculator or in another class. And then in which case the decimals really aren't that big of a deal as they are right now for us.